Good morning, Tehmina Khan is here in TKMaths Edexcel. In today's video, we will continue the lessons on inequalities and identities. It is a part of the syllabus of Year 11 for the Maths, Pearson Edexcel. In the previous videos, we have covered concepts from 1 to 4. Now this one is on 5 and 6. Divide a polynomial and factor theorem. So we will learn here the division of long division of polynomial. One example I have taken here to explain it to you. So let's start. So x minus 3 is a divisor and your dividend is x cubed plus 2x square minus 17x plus 6. Now, in polynomial division, you look at the first term, which is x in the divisor. And you have to cancel x cube, which is the first term of the dividend. So x multiplied by x square will give you x cube. Then you will multiply 3 by x square. It will be minus 3x square. And then you subtract like you do number subtraction when you do the long division. For example, here. When you subtract, the sign of 8 changes into negative. Similarly, these signs will change here. This will cancel and you have 5x square. The remaining terms you will copy down. Now, again you will multiply by this x, a term, to get 5x square. So x multiplied by 5x will give you 5x square. Let me take this pink color. Okay, it will give you 5x square. Then minus 3 will also multiply by 5x. So it will be minus 15x. Again subtract, sign will change. This will cancel out. And you have minus 2x plus 6. Now, you will again multiply x of the divisor by a term to get what? Minus 2x. Because now in the remainder, your first term is minus 2x. So x multiplied by minus 2 will get me minus 2x. Where minus 3 times minus 2, minus 3 times minus 2 will give me 6. Subtract, cancel, remainder 0. So it means x minus 3 is a divisor, is a factor, and x square plus 5x minus 2 is also a factor of this dividend. Just like in the division of the numbers, if you get a remainder 0, then it is called 5 and 2 are factors of 10. So I can say x minus 3 and x square plus 5x minus 2 are the factors of this dividend. Okay. Focus here is the long division technique. Now this one is for you to test your understanding. I will show you solutions slowly and you can match with your answer. So you can put the video on pause and once you are done, then play the video and we will check the answer. So I will show you slowly. You can check your steps. I have used different colors to make it more prominent. If anything is not clear, you can write in the comment and inquire about it. I'll explain. So once remainder is 0, I got the answer. Quotient is a factor, divisor is a factor. So my answer is the quotient. Okay, in long division, this is what happens. The main purpose here is to learn how to do long division of the polynomial. Now let's connect it with the factor theorem. First of all, we need to understand what is a factor theorem. Factor and remainder theorem basically helps us to save time in certain questions. We can do it without going into the long division. So let's see here. First of all, what is a factor theorem? I have already explained it to you. In number system, if your remainder is 0, then divisor and quotient are your factors. But in polynomial, what does it mean? Now this language, if f of x is a polynomial and f of p equals to 0, then x minus p is a factor of f of x. Very few people will understand this language at first reading. So let's understand this with the help of the example here. So for example, using the factor theorem, you have to show that x plus 2 is a factor of this. Earlier, we have done through the long division. Now we want to show this using the factor theorem. So what factor theorem says, if you focus here, this is your divisor. And from the divisor, the value of x you are plugging in the function. So this is my function f of x. And from the divisor, because I have to show that x plus 2 is a factor of this function, I will get the value of x. The technique is put it equals to 0 and get the value of x. Now this value of x you will plug in here. So let me say, let f of x equals to this whole function which is given to us. And now this value of x which I have found from the divisor, which is minus 2, I will plug in here in place of x. And if my answer comes 0, then I can say it is a factor. So you pick up your calculator quickly and you can check it. I will also check very quickly. So it is minus 16, 12, 24, 4 is equals to 0. When you get the answer 0, because this gives you remainder, so it means remainder is 0, so x plus 2 is a factor. So I can say, hence, it is shown that x plus 2 is a factor. Is a factor of f of x. And now if you read this language again, mathematical language, very important to understand it. So what it was saying, okay, if you have a polynomial f of x, right, which I have taken here, and from this f of x polynomial, if your remainder is 0, because this gives you remainder, and p is the value you are getting from the divisor, you substitute in it. So I've shown you through example here, okay, what does it mean. So now let's do this question together. And we will show this question with the help of factor theorem and with the help of long division, algebraic division. So very quickly I'm doing it here. I did not solve it in advance so that I can do it one more time in front of you to recap the concept. So x minus 2 is a divisor and I will divide it. Okay, so let's start. X times x square is x cube. Then minus 2 times x square is minus 2x square. I will subtract, signs will change. This will become 3x square. I'm copying down. Then x multiplied by 3x will give me 3x square. Minus 2 times plus 3x is minus 6x. I will change the sign and subtract. So it is 2x minus 4. Now x multiplied by plus 2 will give me 2x. And minus 2 times 2 is minus 4. So now with the help of long division, algebraic division of polynomial, we have shown that remainder is 0. So proven that x minus 2 is a factor. Now using the factor theorem, what we will do, from the divisor, I will get the value of x. And this value of x I will plug in the function, right? So function is, let me write here. So let's f of x is equals to x cube plus x square minus 4x minus 4. So in this one I will substitute 2, which we have found from here, and answer should come 0 if it is a factor, right? So it is coming 0. So we have shown that x minus 2 is a factor of f of x through algebraic division and through factor theorem. Now one question is here, this one I will solve with you, and next question is for you to test your understanding. Okay, little different. It is given that 3x plus 2 is a factor of, let me write this function here, f of x is equals to 3x cube plus bx square minus 3x minus 2. Now there is one unknown b, but information is 3x plus 2 is a factor. So let me get the value of x from here, and this value of x I will substitute here, right, in place of x. And remainder should come 0 because it is a factor, it is given to you. So I'm replacing this whole thing by 0 because this gives us remainder. And after that we will solve very carefully to avoid any mistake. So it will be because it is a square, it will become plus 4b upon 9. 3 will cancel with 3, plus 2 minus 2, right? So this 3 I can cancel with this one. So I am getting minus 8. Achha, these 2 will also cancel out. Minus 8 over 9 plus 4b over 9, right? So I'm bringing it to this side. So 9 will cancel with 9. So I get b is equals to 2. So first part of the question is done, which is find the value of b. Hence factorize completely. Now this is a cubic equation. So your cubic equation is now substitute the value of 2 in the equation. So we had 3x cube plus 2x square. I am substituting the value of b minus 3x minus 2. Factorize completely means you have to find the other factor. Now one factor is already given to you in the question, which is 3x plus 2. So what I can do here, I can do long division to find out the other factors. So let's do it here. The linear factor was 3x plus 2. Okay, so 3x plus 2, and this is 3x cube plus 2x square minus 3x minus 2. Let's check it is correctly written so that there is no mistake. 3x cube plus bx square minus 3x minus 2. So let me take it to the next page, otherwise this space will be little to do it. So let me do it here. Okay, so now we will do long division here. 3x multiplied by x square will give me 3x cube. Then 2 multiplied by x square is 2x square. Now when I will subtract, this will cancel out and this will also cancel out. So what I'm left here with, minus 3x minus 2. So after that it is 3x multiplied by minus 1 will give me minus 3x, and plus 2 multiplied by minus 1 will give you minus 2. Subtract, sign will change, and you will get 0 remainder. It means your other factor is x square minus 1, and this factor was already given to you. And if you recall, this is algebraic identity, so which is equivalent to this one, right? So I will factorize it further it will become x plus 1 and x minus 1. So finally, question says factorize completely. So I can write all the factors together. I can say the factors are 3x plus 2, x plus 1 and x minus 1. So it is factorized completely. So now this question is for you to do it, and you can put the video on pause. I have not solved it, but I have written the answers of P and Q here. And one hint I would like to give you here, because there are two factors given as there are two unknowns. So it is little extension. So when you will solve this question and you are putting f of x equals to just one line I am helping you to write, those who are confident can put the video on pause. Do not listen my explanation. But it is for those if you find it difficult. So from here I will get x equals to 1. From here I will get x equals to half. If you put it equals to 0, right? So one time you will put f of 1, put it equals to 0. You will get one equation. Then second time you will put f of half and put it 0. You will get two equations. You have to solve them simultaneously, right? So this is the hint for you, and you should get answer P6 Q minus 13. So I hope you got it right. Thank you very much for watching the video. Please press like and subscribe button and share it with your friends. Do write comments about the video. Thank you. Take care. Bye. Allah Hafiz.